Hi, I've been designing a new PCB for my radiant half-bridge circuit, and I'll show you the build process. I'll be talking about the parts that I used along the build. As this is still a prototype, I will encounter some challenges that need to be fixed. Alright, let's build a radiant half-bridge. These PCBs just arrived today. I'm really happy with them because they're blue, and blue is one of my favorite colors. And I'm gonna assemble it today. And I'm gonna record it so you can see how that all goes. Let's point out a few details. For instance, I have here two diodes places. I will only use one diode as I have the 900 volt MOSFETs here that only need one diode, but I wanted to see if I can use 1700 volt MOSFETs also, and then you need two diodes because the diodes can handle 1000 volts each, and then you need two for the 1700 volt maximum. I labeled everything out, and you can find it back on the website that I will link. And yeah, what should I say? One of the things that makes this possible without batteries is this little gimmick. It is a isolated DC to DC converter, and this little thingy, you can input 12 volts on one side and you get out 15 volts and minus 5 volts and a 0 on the other side, and these are isolated from each other. And that is really important for this kind of circuitry, the isolated DC power supply. Normally I used batteries, but yeah, they're so bulky and I wanted to get rid of them. So if I have a circuit that runs properly, I can leave it on for weeks without worrying that the battery will drain, and this way I won't need any batteries, which is really nice. But these tiny things have one problem. They are not made for through-hole assembly. They have no pins. So what I did is soldered some pins on them. And that was fairly easy because on the side there's a small ridge with plating, and you can easily mount some wire. Just solder the wire on it and then cut it off at the right length. And now the fun thing is, this should fit. And does it fit? Well, let's take a look. I've pointed it out here, the two places, and well, does it go in like it should? Does it work? It seems to be outlined fairly good. The wires are a little bit out of place, so I need to bend them a little bit. Let's start out with the longest pins and then bend them into place. That looks pretty good. Almost in. Almost in. These aren't in, so I need to bend it a little bit that side. Yep. Twist it, bend it. I don't like SMT. Surface mount, it's all too small. I can do it, and I have done it because further on you will see. the gate driver IC is surface mount, but I converted that to a through hole chip, which makes it easy to recycle and convert, and I believe it's almost in. It is in, but it doesn't go in because I've got too much solder on it, I believe. Or are these pins still sticking out somehow? Oops. No, this is not the proper way I should adjust this. I should do it slightly different. And I will turn on my soldering iron here so I can see if I can make it fit properly without too much hassle, because this is just a prototype. I want to see if this is gonna work out. I'll probably do the other upside down. First the pins, the wires, then solder wires to the small PCB. That will probably work a lot better. Let's see if it will fit now. Where is the problem? These are all fine on the top. The bottom big ones look good, but they don't go in, so I'll give them a bit of heat to see if they slide in. No. Yes. I have to be careful because now it's gonna stick. These are not fully aligned. Yeah, I'm not gonna do it like this anymore. I'm gonna do it the other way around. Yep, there it is. It snapped in. But that is only the top side. Now I need to snap in the bottom side. I already see a problem rising because there's a little wire that's getting loose. And that's a non-connected pin. So that's not what I wanted. Even if it doesn't go in all the way, it doesn't matter because I already am able to connect it, solder it. Okay, those pins are in. Now I need to. That's the one. That corner one wasn't good. Alright, it's on. It floats a little bit. Let's see, how does this camera work nearby? Maybe I should turn on auto zoom, but you can see it. It sits on top of it, and it's fine with me. I can push it in a little bit more and then solder it. Yeah, I'm gonna tighten it up. It's not getting any better, so. This solder is 0.75 millimeters in diameter, and it has flux, of course, else it won't work. So this is the 15 volts pin. It's the 0 volts pin. I'm having a temperature of 350 Celsius. It's a bit high, but I like it. So everything flows and you can solder it really easy. Yeah, looks good. Okay, the other pins are going on the bottom side. I can also inspect the other ones. This is really... well, all pins are essential, of course. Let's put this on here. That one. That one. Okay, it is in. I like it. It all looks good. By the way, normally I use a looking glass to solder, but now I'm recording and it will be all in the way, so that wouldn't be nice. Another detail is that I would normally start off with all the low, small things like the wire bridges here. The BR are wire bridges from the source to the 0 volt of the isolated DC converter. And those need to be bridged because I had to get the -5 volts to the other side of the gate driver IC. So that's why this is a bridge cable. And here also. There also needs to be a bridge cable on the diode. I put that on the bottom, I didn't put it on top. So here's a bridge for the diodes, and here's the bridge for the source to 0 volts. Alright. Well, let's put the other one in and see how that goes with solid wire. Strip some off, twist it, and solder it in place. Yep. That should be fairly enough. Twist it up. And solder through. Yeah, that works. Gonna get a little tool to help me out. You know these things. It's a third and fourth hand. Really easy to use in these kinds of situations. And we got the solder. And we got the wire through the hole. So I'm now gonna solder the second isolated DC to DC converter. But instead of soldering the wires to the isolated DC to DC converter, I'm going to first hook up the wire to the PCB and see if that works better. Holes are barely enough for the wire. Yeah, it works. It's fine by me. And if I put enough solder on them, it's thinning the wire, so that way the next hole is even easier to get out. Let's see if I can do this a little bit easier. Can I fixate it? Yes, of course I can. Come on. You can do it in the mix. Get a little bit more in and solder it. If it's too long, I'll just snap it off. Get enough solder on the wire so it will stick to the PCB. So this is a little bit more work than I intended to do. You know what? The non-connected, I'll skip those. Then I'll have only 1, 2, 3, 4, 5, 6 wires to do. Maybe even 5, because the 5-volt supply has a double connection. But it's used to discharge the gate. So I prefer to have both of them connected, as high currents will run through them. Oh no, I've done the non. I just said I wouldn't do the non-connected pins, and I just did. Doesn't matter. Little extra work. Alright, another one. This is the 0 on the DC isolated side. And another pin. That was a little bit long, so I snapped it off. I'm really glad I waited all day for the PCB to arrive. And it came in the evening. I don't know if you do it, but if you're waiting very eagerly for something to arrive, I listen to all the traffic. And if I think it's there, then I will almost rush to the front door. And often I'm correct, and I'm waiting for them to get the package out. They don't even have to ring the bell. I ordered it by PCB, JLC PCB. They gave me a nice what is it? PCB and mobile holder. So this was supplied as a gift, and you can put it down like that, and you put your phone on it. That's really nice. I like that kind of presents that are functional, because they're they also send some other stuff, but that wasn't really interesting. Alright, let's continue. Last wire. This is into the second minus 5 volts, which actually isn't necessary. But I'll just put it in here, tin the wire so it doesn't mess up. Yeah, that's not so nice. I should make the holes a little bit larger, because now the tin already makes the wire too thick. I have to get it off and hope it will go in again. And it does not, so I'll snap the end off. Let's distort it and hope now it will go in. Please go in. Yes. It always helps to ask politely. Something I've learned through the years. Alright. Snap the other end off. This is pure copper wire. It's really thin. I have left it lying around. Really don't ever use it. But for these kinds of stuff, it's really good. So, I'll get it out of the little thingy. So now on this place where the second isolated DC to DC converter is going for the low side MOSFET, this is the high side. The circuits are all separated, and well, you'll see they're not completely separated, of course, because I supply power to the non-isolated side from only one point, so 12 volt enters here and goes regulated into the DC to DC converters. Now let's see if this one also fits. It will fit, of course, but how will that work out in assembly? I see my pins are all wonky, as some guy from Britain would say, which I'm not. I'm from the Netherlands. I am Dutch. A Dutch guy working on the replication of solid state Tesla technology, and that is Nikola Tesla, not Tesla Motors, although maybe, you never know. I'm not work with them. Well, this fits really nice. I really like how this looks. It already is in place in the correct sense. I'll only have to solder it and then it's all good. Amazing. Yeah, let me solder that in place and snap the wires off that are too long. No, these wires. I've got these large wires for the diodes. Let's see if I'm still recording. Yes, I'm still recording. Alright. So this one is going to be soldered right now. What I'm doing is the pins are connected to the side of the DC to DC converter PCB. There are little slots there the pins fit right into. They snap right in, and it's gold plated, and I just solder the wires right into that. This is really the preferred method. I should have done the other one like this also. A little bit of tin, a little bit extra, and that's it. This is really tiny work. This is probably one of the finer things that need to be done. Let's look now. The pin is somehow out of place, and now it's in place. I will have to check out if it's all right connected. You probably won't see what I'm doing right here because it's so very tiny. Maybe I can zoom in when I'm editing this so you can see what I'm doing here. So these are the 5-volt pins, 2 pieces. And here is the non-connected pin. I'll give it a little bit, doesn't matter if that's connected. And this is the minus from the 12 volts input. I use a 12 volt input, isolated DC to DC converter, for the reason that I want to use the 12 volts also for the fans, because it's not really necessary to cool, but I do like to use 2 fans in series. That will come on later, of course, to keep it cool, and these are powered from the same 12 volt supply. Look at that! The first 2 components that make it possible to use this circuit board without a battery, an isolated battery, like I did before on the high side switching module. And remove the pins that extend to make it neat. It's good to be neat, especially with these kinds of circuits that are so high in frequency. Wow, I like that. I won't test it right now. I will test it. Well, I can test it, of course. I've got a nice little testing device for that. That will beep. This is the beep. If I'm connected, it will beep. So this is the positive 15 volts. Good. And 15 is not on the 0. Or this minus 5. Let's see, what was it? This is the 0. Hey, is that good? Is that correct? Have I already spotted a mistake? Yeah, that's not good. The 0 and the 15 volts are connected. That should not happen. Let's see if it's the PCB. or if it's something else. PCB is from here to there. It's a really small path. There's no connection. This is it. So it's not the PCB. Could it be internally? If I reverse the connection, is it then still shorting out? Oh, why is it? Somehow it turned off. Maybe the battery is slow. Okay. Yeah, it clearly says that it is both ways. That's not good. Is that on the other side also? Yeah, that's also. That's really strange. Have I already made a mistake? Oh, so soon. Well, it's good to know. It's still a prototype. But that should not happen. Let's check out if a normal... because I got a few more of these. Where are they? This is the wrong box. Okay. I've got another right here. Come on. Cable is in the way. This is the same connection. Yes, it does. Okay, my battery's really low. But it did short out, so it's normal for this port. Which is pretty weird because it's the 0 and the 15 volts. Oh no, I hope it isn't mirrored. I should check this. Maybe. Maybe. But it looks like it follows the outline pretty well. Yeah, it looks like it's correct. So it should be on like that. I'm gonna check the circuit board, the drawings, because that should not be connected at all. Let's check again if this battery wants to give out a little beep. Yep. This is the 5 volts. Let's see. This is the 5 volts. It looks like it's not shorting out, and it isn't. Oh my god. This is the 5 volts. And that is the 0 and minus 15 volts. Oh, that's a good error. Okay. Well, that's not a good error, but now I know. Ah, that's not so nice. I'll check the PDF file. Okay, take a break, check the file. Okay, I looked at the spec sheet, and it has become clear to me that the picture, which labels out the pads 1 to 8, was upside down. This wasn't clear to me, so now I learned a hard lesson. But actually it's not that hard, because my solution is already present. Because this is the top side. I've got 5 of these PCBs. That's really nice for prototyping. You can make these errors. These are now in reverse. They should be connected like that. Well, of course that is a little bit troublesome, because then, well, it's not ideal. So instead I flip over the circuit board, and now this is bottom, so it's mirrored. Now I can put it on like that, and that is the same as having it upside down. Solution! I like that. So yeah, this board will be I'll probably disconnect these two because they're, I believe, 5 to 7 euros each, but they serve their purpose. So this is going away, and I'll fix this the proper way. Yeah, that's prototyping on the bottom side. Now, well, I'm very glad I have the solution already, because I won't need to redesign the PCB, order it again, wait and solder, and I can just go right ahead and make it fit. Although here is a fuse, so I should check if that is not gonna compromise anything. And let's see, where's the fuse? That fuse was really big last time I checked. Where is the fuse? Somewhere. I put it in the one of the many storage boxes, of course. Yeah. Yeah, when you prototype, then you order all these kinds of things, and you have to put them somewhere so you can find it back, but then you end up with a lot of boxes with parts. Oh, there they are. And you still have to find them. That's why I really like those transparent boxes that can help you find everything if you need it, especially with the small parts. Okay. This is the fuse holder. It's really bulky, and it's to be put right here. Let's see if that fits. And it's also a very tight fit, but it does fit. Yeah, that's pretty good. Pretty neat. Well, good enough for me. I should really tighten, make those holes a little bit bigger, because it's not really ideal how it sticks in. It should be easy. And there's the problem. Now it won't fit. It will fit like that, but those two pins down there, which are, that's actually only one pin. It's the positive voltage supply, the positive 12 volts. I should probably be able to work around, but it's not ideal. This part was delivered as being 0.5 centimeters wide, but it was 1 centimeter wide, so that's not really my problem. And here again we see the solution. We can disassemble it. It will still work as a fuse holder. You just get, why is that one so loose? Because it's made in China? With all due respect, China, I know you're not watching because I believe YouTube is censored in China. It's just really sad. Maybe Starlink will make it able for Chinese people to watch this. Let's see, I put this in here, this little fuse holder, and I put that one here, little fuse holder. Yep. Solution. Now I can do it the right way. Yeah, that's gonna work. It's not ideal, but good enough. It's the 12 volt supply, so it's really nearby, but it's no problem at all. because it's at the near 12-volt entry point of the DC to DC converter. Okay, now, well, good to know. I'll take a break and then I'll continue with this, because now I need to reconnect the wires again and do the work all over what I just did. Yep, that's why I haven't made a video for such a long time, because I built a lot of stuff that didn't work, and I rather continue working than recording a video, editing it, which costs a lot of energy and time. I'd rather show you my results, and this is worthy of showing you because I already tested it. It already works. How nice is that? Very nice. Okay. Didn't I mention I would get a break? Apparently not. It's one of these things, and once you're busy you just want to keep on going. So I'll keep going and see how far I will get. Don't plan too much, because you never know how it's gonna work out. Let's see, I need to enter the wires from the other side now. Yeah. This looks a little bit funky, so I'm gonna cut that off so it will stick through again. So, yeah. When I first saw the PCB, I already thought, I thought to myself, I have lined those out on the bottom of the board. That's not really, they should be on top, but solution, they should be on the bottom, because then they are mirrored and they will be connected in the right way. Okay, snap. Let's see where I need. This is the -3. And now I will skip the non-connected pins. Ooh, that's really tight fit. It does go through, but it needs to be longer. So I'm gonna pull. No, it's not gonna pull. I'm gonna solder it. It will be fluid, and then hopefully it will move through. It is hot and it is stuck. Let's snap a little bit more off. See if it works. Okay, I really should enlarge these holes. So if you're gonna make it yourself and you order a PCB from me, then it should be easy, or at least easier. Okay. A little bit more. So the other side is tinned. Yep. Snap it off, next one. And now the 0 input voltage point. Just like that. Right. Looks good. That's good enough. So now I will skip the non-connected pins. I'll go to the -5. Please go in. Please enter. Yeah, here's the same problem again. I didn't tin it. The wire needs to be tinned because the wire is so small that it will scramble at the end. And then at the same time, when I tin it, there's too much tin. It becomes too thick. So yeah, this is all work that's gonna be easier in the future when I redesign this PCB. Now I skipped the not connected, and again I have too much solder on it. Unbelievable. It's a really tiny hole. Maybe I should make a note of it, so I'll never be able to forget it. Or maybe I should redesign the PCB. No, I'm gonna write it down. It really doesn't go in. Man, this is troublesome. Well, that is not a nice job, I tell you. Come on. Well, it's gonna be good enough. It has a little wire sticking out on the bottom, but that doesn't matter, because it's the -5 volts and it has a double connection. Okay, snap it off. Snap this. Well, take a little solder. Why is this paper lying here? Okay, snap the wire off. Make it a little pointy. Maybe that helps with going in. No, it doesn't. Okay, this is really nasty. This is not a funny job anymore. This is one of those things that you think, maybe I should have taken that break, because this really demands that you, come on, keep being patient. Keep your patience. I'm not a patient. I am patient. English can be funny with words. The double meaning. Snap off. Let's do it straight. Straight. Put it in on the -5. Please go in. Please enter. Please, 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 please. Nope. Oh, this is really, really, really not funny. Why doesn't it go in with that? Maybe there's a... Yeah, it's in. It's in. I remember that I had the same troubles with the other PCB. Maybe the hole's a little bit smaller. I can't imagine how that can be, because it's all automated design by robot. China. 0 volts, yes, 0 volts goes in smoothly. This will be connected to source of the MOSFET. And snap it off. Let's see if that will work. Enter the 15 and it does work. Okay, now I'm on a roll. I'll continue. Alright. I'm glad I did that test. And that I didn't go on soldering, because if I would have continued soldering this, I would have to desolder this one and have a lot of more trouble, and now I can just continue with a new board without wasting a lot of other parts. Okay, nice. Upside down. Now I have to really carefully. This is the input side, yeah, so this is the input side. Well, the outline is still correct, so it's actually hard to make a mistake. Yes, this is a mistake. You can see that the outline isn't fitting, so I should swap it around. Correct the pins like that. And it fits like a glove. I like it. I like it. I like it. It really looks good. Alright. Pins are good. Can solder it into. Let's see, this is the 5 volts then now. This is the 0 volts. This is the 15 volts. Keep a clean tip, especially with this tiny things. Heat it up, solder it. Heat it up, solder it. Looks good. And this is the 12 volt supply, I believe. No, that was 12 volt. This is the 0 volt. That's because I'm on the other side now. You see these volt. Alright. Now snap off the leads. Test it again. Yes. This is the patient part. Done. The pliers I'm using are Knipex. You've got a nice hard beak with a cutoff. You can really enter the board. It's for maximum copper, 1.6 millimeters diameter, and iron 1.2 for cutting. So it's really for tiny stuff. Let's inspect. Yep, everything looks really good. Nice. Well, since should I solder this holder? Yeah, why not? Let's put the solder in on the fuse holder, because else I might forget. Put plenty of it in. It will also power the fans, which draw a little bit of current. Let's not exaggerate. So, yeah, I could have left this in probably. Doesn't matter. With the fuse in it, it will be good enough. It will be upside down. That's nice. There it is. Looks good. Okay. Now I'm gonna take a break because I've got another one to do, and this is really demanding a lot of me. So, until the break. Alright, let's continue. It's a bright new day, the sun is shining. I came to the conclusion that I could have soldered the fuse probably on the top side now. Although, no, there wouldn't be enough room. So yeah, it's not ideal because the bottom side will not be as accessible. So I will need to think that over. If I can redesign it a little bit so the fuse can be on the top side, that would be nice. Anyway, put on the soldering iron again and continue with that isolated DC to DC converter that could be recycled from here. If I could disconnect it, I could chop that one free. That's really a waste if I wouldn't use it. But is that gonna work? I don't know. This is far from ideal. I'm ripping it off. No, that's not good. This one is already wasted. That's not good. desoldering it might work, but there are 8 pins, so I'm gonna leave it for now and take a new one from my supply. Luckily I have more of them. So here we go again. Twist the wire and solder it, and then cut it again because it won't fit in the. I need a yes, a notation for all the arrows. So I will know what to correct. So first are the holes. Widen holes of ISO DC. And the next is I should flip DC, or keep it on the bottom side, which I'll probably do on the bottom. Then I should remove the top. Remove top silk. So this image will disappear from the top side, so it won't confuse us. And then the bottom silk will need to have the voltages to bottom silk layer. Where's my water? I don't have any water. I don't have tea. I should get some, but I just started, so. Okay. Let's have some solder. Cut off the excessive part. You noticed I put the cap on the pen. This is to indicate I won't expect any errors anymore. We'll see. Okay, so I need to enter from here. And it does work. I just have one single wire that is not soldered together with the rest. Again, cut it off. And now I hope it will work again. Let's take this part again. Maybe I also should wear the electrostatic wrist wrap. That couldn't hurt. Okay. Put the board in again. And this time, let's see, I have to come from here. Yep. Put the wire in. Skip the non-connected. Yeah, now it fits. Perfect. Don't drop down. So, another few of these wire leads. That's the first of 6. And I can put my phone again on the nice stand. Nice. Skip the non-connected, as they are useless. And this is the input voltage. Yep. See, now I have the patience again. It's good that I took a break. Because this kind of work requires patience, a fresh state of mind. I keep the soldering iron a little bit longer on it, so the other side will heat up and guide the flux through the hole of the PCB, which then in turn flows the flux also on the copper wire. So when I snap it off, it has some really nice flux on it. It won't twist apart. So far so good. Now the 5 volts also fits great. This is going a lot faster than the other ones, which means I'm on the right path. Everything doesn't work out, then you're doing it wrong. That's what the universe is trying to sell you to you. Alright. And that is the last one. Perfect. Let's check it. Here it is. You see that some not this one wasn't perfect. This one also. Alright, looks good. Now, what I thought of is that this isolated DC to DC converter, it has these slots on the side of the PCB, which is an SMT device, surface mount, and these slots on the side will connect to the leads that I just soldered. They are gold plated. I'm gonna fill that up with some solder, so I'm sure that when I heat it, it will connect properly. Yep. Like that. It's perfect. Let's see, can I grip it here? Yes, I can. Be careful. So, clean the tip. Put some solder in the channel so the wires will connect properly. That's it. And then I can connect it to the board. This is the correct way. Is that going to work out? Wait, let's first straighten those pins as they are a little bit scrambled all around the place. Put them straight so it will line up with the board. I can connect it properly. Alright, this looks good enough. Put it in. Yep. So yeah, now I see the solder is not fully aligned anymore with the wires because it's sticking out now, so that wasn't a very bright idea. I have to not do that again. It will still work. Yeah, it will still work. Just have to be very clear in how to solder it. Let's start off with the sides here. They look good. Clean up the solder tip again. It's always important. Can't state that enough. A little bit of the flux to guide it. Heat it up. Yep, in place. Nothing wrong with that. Oh wait, I'm soldering the wrong. Oh, that's funny. I should solder that one. Yep. Alright. I hear my neighbor is already playing his favorite game and yelling at his console because it isn't doing what he wanted to do. Yep. The early stages of AI are very frustrating for him. Okay. Another one. And another one. That's it. Okay, let's chip off the ends that are not that long this time. Very well done. Estimating the length. Alright. Well, they are on now. And it looks good. All pins are connected. There's a little message which says to me, I got a free sample email from China, and I get this reply: thanks for your reply, free sample 5 pieces, but shipping costs need to pay at your side. Sample shipping costs $45. Waiting for your reply. Okay, well, I'll cancel it. Cancel it. Funny people. $45 for a keychain. Only shipping costs. How to make money. Yeah. Okay. This battery was almost dead, so I'll get my other multimeter. Actually, I have another one, but I'll use this one because it's fine. It's so fine. Alright. Beep. Beep function. So now I'm going to the top side. No, this is a little bit harder, but I still know what I'm doing. This should be 20 volts. And now I know that that is 20 volts. No. In reverse now. Yeah, this is the -5, so this is the -5, which is here. Correct. All right. Then this is the 15 volt, and that one is not shorting out as it did before, so now it's correct. This is good. Also not shorting out. Great. And then we have the input. Where is the input? This is the positive. That should be here or here. Oh, it's not. There's no fuse, so it should be here. No. Yeah, and then ground. Ground should be. Yep. Okay. It's not the best test, but for now it works out. So this should be 15 volts. 0 volts. 5 volts. Yeah. Checks out. And then from here to there. Positive doesn't seem to work out, but that is probably because I don't have all the connections yet. Negative. Negative is good. Why is the positive not connecting? Because it's connected by the inductor, which is over here. And then, yeah, that all probably is good. I will check again in a later phase. So now the DC to DC converters are on the bottom side of the PCB board and not on the top side. So I have to correct that, and I have to widen up the holes because they're too small for the wire to pass, and this is even a thin wire. Usually I have thicker wire. Oh yeah, what I also thought of as a solution is not using wire, instead using clippings of the parts that will come off, and just use the clippings to be soldered through the wire, and those do work fine. So that is the solution. That's how I'm gonna do it in the future. Don't use wire, use cuttings. So the widening up of the holes isn't necessary. So I still don't have to adjust the PCB right now. That's nice. Okay, get that one out again. It's not needed. Well, I have the wire here lying around here, so I can now do some bridges. Maybe I should also label out what is top and bottom. Label top and bottom. Although it's clear because nothing is here, and here everything is, so yeah. Diodes. The diodes, they need to be bridged in this configuration. As I now do only use one diode per MOSFET. What is easy? What is easy? I'll just guess it. Okay. Put the wire through. And bridge the diode, which is only used when used 1700 volt SiC MOSFETs, which I do not have right now. Yep, that looks good. Put it like there. Oh, that's perfect fit. Nice. I love it when it turns out to be a perfect fit. Connect it here, solder it there. One wire bridge done. 3 to go. Okay, take the other. I am bridging the middle diodes, because the other diodes have their heatsink that connect up to the holes. Although, wait a minute, I'm doing two things at the same time. It works actually really good. So you're learning along the way. After a while you get things really easy and you can speed up assembly time. So I'm already way in with the assembly time. I think I've been working 1.5 hours already, which is crazy long for the amount of progress I've made. But that's because this is a prototype and there are errors to be Yep, bridge 1, bridge 2. Now the source to 0 volt connection, which is also bridged for both MOSFETs. Very important connection, because this connects the source of the MOSFET to the isolated DC to DC converter 0, which makes it a reference. We need that reference. Now I made these holes bigger, so that's really nice. Now I can use the wire. Yep, perfect. Put it. Oh, there's my timer. Half an hour. Okay. I should do something here. Hours. Okay. Then I'll put my timer on again. Timer. Timer. 1.5 hours start. Okay. Back to the wire bridge. And put it in place like so. And solder it. Easy. So now I'm starting where I actually should have started, at the low side of the PCB, and low I mean the smallest parts, because once the bigger parts like the capacitors are on, you don't have access to the board anymore as easily as I do now have. That's why you always start with the smaller parts. Come on. Twist it. And put it in the bridge, which has a larger hole. And my neighbor is screaming at his console again. The AI must have messed up his game again. I wonder why he stays playing. Must be the addiction that the game is generating. A little bit of solder on the copper of the wires. It's not needed, but can't harm. So the 0 volts source wire bridge passes the -5 volts discharge. And is that a problem? No, it is not. Okay. Next, what's up next? I've got some small capacitors here I could do. Those are the multi-layer ceramic 0.1 microfarad capacitors that bridge the +15 and -5 volts. Let's get them here. I need several of those, so I'll put them all in place if I can find them. Yep, here they are. Yep. 100 nanofarads Z5U5, it says here. Let's get some out. How much do I need? 1, 2, 3, 4, 5, 6. No, I'm gonna not use those. It's a bit much. So 1, 2 back side, 3, 4 top side, because I use it for the 5 volts of the input of the gate driver IC. Put this back. Yeah, that's enough for now. These have no polarity, so they can put in anyway. I just cut them off the paper like so. Paper won't be used. Throw it away. Now first the bottom. Let's put them in C15 and C21. 0.1 microfarad or 100 nanofarad, which is the same. Turn it around, bend them a little bit so they stick in place. Solder and clip them. I put these on the bottom because on top is the isolated gate driver IC in a socket, tip 8. Snap those little leads so the socket can be put in place. I don't like how far this sticks out. This is the fuse, so I'll trim that also. Righty. Let's put the gate resistors in. Oh no, I almost forgot I got two more. Could have done that at the same time. Those are C5 and C2 on the top side of the board. I believe the bottom side is now finished. Yeah, bottom side is now finished. So all the added components will be now added from the top. I should... No, that's correct. This is labeled on the bottom and not on the top. Yeah, that's good. Okay. Label parts on the right side. That is really important for assembly if you are following instructions. I don't follow instructions because I worked so much on this circuit board that everything now is in my mind. Alrighty. Let's snap them. Snap them leads. These small capacitors. Ow! Stick it in my finger. I got blood. Blood, sweat and tears provided. Okay. Let's find something else to do. I wanted to do the resistors. The gate drive resistors. The gate resistors. I used 8.2 ohms, but I'm gonna use the 10 ohms. Why was that again? To be safe. To cut out ringing, yeah, that's fine. It works. So I need 4 of the 10 ohm resistors. 4 10 ohm resistors. And they are R1, R2, R3 and R4. On the top side these are 1 watt resistors, metal oxide. It's a bit high rating because they never will use that much power. But the currents are pretty high that it go past through them, so although it's a small amount of time, it's a lot of energy that passes through them. And metal oxide is best for the gate driver gate resistors, metal oxide. I don't know why exactly anymore. I just forgot. I just know it. There's a reason for it. Probably the way it is constructed, which has very low inductance, because it's a resonant circuit that is being damped by the resistor, and if the resistor itself is becoming resonant by having inductance, that wouldn't be ideal. I believe that is the reason, but I forgot. That's fine. Sometimes you just need to forget a lesson that is learned and just apply it. So these clippings that I'm using here, 2, 4, 5, 6 would be very useful for the isolated DC to DC converter. Very nice. Okay, resistors are in place. Let's find another job to do. Something small. I got the LED here. And yeah, let's put in the LED. LED with resistor. One LED, one 140 ohm resistor. That's a little bit too small of a resistor because it becomes a little bit hot, and the LED doesn't need to be that high. I dropped my where's the other one? Doesn't matter. I dropped this. This is the DC to DC. No, the 12 volts power supply. Oh, that fits nice. Last design didn't fit. So I can put this one in as well. Let's try the other one also, because I have a bigger socket as well, which is much more expensive. This is the bigger part that is going like this into those holes. Well, that doesn't fit. That is a little bit of a miscalculation, or I should wiggle it. Yeah, it fits. You see the fuse is exactly fitting in. That would have never worked when it was on the top side, so that's good. I still have the fan pins. The coax. The coax seems to be very near. So is that gonna work out? Let's get the coax. A coax. Coax. This is the one of the inputs of the gate driver IC. The square wave enters through this BNC connector, and I planned it to be right here. Stick it in. Amazing. It does work. It does fit. I really designed it properly. It's a really tight fit. Yeah, I'm gonna leave this in and solder it right in together with, I'm not gonna use this one anymore. Didn't I? Oh, the LED. Here is the LED. Polarity should be like this. The long one on the right, flat side on the left, and the resistor of 140 ohms that is calculated for the 5 volts. And is that an error? Yes, this is an error. No wonder it gets hot. I should correct that one. This is not the right resistor, so resistor, yeah. LED resistor is 12 volts, should be 5 volts. There it is. Yep, I'm not using the 5 volt supply. Instead I'm using the 12 volts. So that is no wonder the resistor got really hot. I'll have to calculate how big that resistor should be. I've got 140 ohm for the 5 volts, and I now have 12 volts, so I should be safe if I put a 1 ohm in. Current should be the same. Can I do that? Can I calculate that? 5 volts is 140 ohm times the amps, which should stay the same. So 5 divided by 140 is the amps. Then I have a 12 volts, a resistor, and the same amount of amps. So I should divide 12 by 5 divided by 40 is the resistor. How much is that? 5 divided by 140 is, put that in storage, 12 divided by memory. I should have a 336 ohm resistor. And then I'll find the nearest one that is bigger. Keep it on the safe side. So 336, and the nearest resistor is, where are my resistors? Down there. 390. I could use 330, but I'd rather have it running a little cooler, because these LEDs won't be used often. Okay, resistor 390, yes, I've got those. Put a 390 in. 390. Some little mistakes that are being corrected. So now the LED is an indicator of the 12 volts supplied and not an indicator of the 5 volts supplied. Is that bad? Guess not. It's acceptable. Maybe I need a lot more of these LEDs, but if it works, it works. Resistor, LED, and the coax PNC for the square wave input from the signal generator. Put a lot of solder on the Bigfoot so everything is solid through and through. And then we have the 12 volts input supply. Yep. There it is. Great. Snap off the leads. That can be used again to make wire bridges. If you don't have wire, should have wire. Dun, dun. Alright. So far so good. I think I need some tea. Small break is in place. really looks good right now. I like where this is going. Making good progress. I like it. Yep. This resistor can go back to the 5 volts LED supply, because they are still good for the 5 volts. Okay. Small break. Alright, had a small break. Got some tea, Bengal Spice, which is cinnamon based tea. I love that one. Got some water. Now I'm gonna continue with the board. And I'm going to put on these sockets, if I can find them. Yes, here they are. These are precision sockets with round holes, which are really nice. And while I'm at it, I can put in the diodes, or diode. Yeah, it's only one. The 10 microhenry inductors that aren't the highest quality, but they should work. Put one diode back. And that's it for now. There's some capacitors here. 100 microfarads. I should have bigger ones. Yeah, that's not enough for now. That will come later. So, put my glasses on. Get some foam, or better, I should have some. Where is that? It's a bit messy down here. That's what you get when you do such a lot of things at the same time. It should be here, and it is there, right underneath the box of capacitors that I never use again because they are too low in quality. Right, am I recording? Yes, I am. Okay, so get some gum blah. These are the precision sockets. These have round holes, and I use those precision for the gate driver ICs. So, put on the soldering iron would be nice as well. Put the rounded circle on the top, so pin 1 is always correct. Stick it to the board and solder it. Well, it's not a perfect solution, but it does normally do the trick. And is it hot? Yes, it is hot. Pin 1 and pin 8. Pin 1 and pin 8. Come on. Alright. So this is now done, and I can use it for erasing pencil lines again. Is that good? It's a little bit, this one should be deeper. Let's see if I can push it in a little bit deeper by heating it up. Ooh, that's hot. No, that's good enough. It will work. Solder the other pins. This is really a job for a magnifier loop, a magnifier with a lamp, so you can clearly see what you're doing, because it's all so small. That's why I wear my glasses, so I can really have some amplification on these tiny parts. Alright, these and yeah, it looks good. Good for me. Now, what I already have soldered but put on another board, another prototype, are the actual gate driver ICs. These gate driver ICs are put on a tiny converter PCB board, which makes it from surface mount to through hole. And I did this with, again, those precision sockets that I will show also, because I'm not gonna do that right now. If I can find them somewhere. Yeah, here they are. So I use these connectors, which have these nice little round pins, and I put them on the circuit board like so, and then they fit into the DIP 8 precision sockets, and on this is soldered the surface mount gate driver IC, which is really small, and this is really tough to solder. This is really something you need to do with a magnifier, and nice thing is that I made them like this is that I can swap them. So if I finish the board and it doesn't work, I need a new board, I just take these out and plug them in again, like so. And this way I can work around the surface mount problem. So yeah, you have to Google for that. It's a converter from 0.27 millimeters to 0.85 millimeters. Yeah. So I'll put this aside again, because as usual I'm not grounded. I should put my static wrist wrap around me so I don't destroy any parts by electrostatic discharge. I don't really worry about that, because you really need to be a little bit charged by something. Are we still recording? Yes, we're still recording. So the diode can be on the top or bottom side, that doesn't matter. Watch the little stripe on it, it should match up. If it's the wrong side around, then it won't work. This diode is to burn out the fuse when it is wrongly connected, because if the polarity is wrongly connected, then the diode will create a shortcut and the fuse will burn out, and so you will have to watch out for the polarity. I should mark it because the markings are now gone. Okay, that is something that I should definitely design. 12-volt polarity markings. Parking in sometimes my markings at fan, because at fan I can make a positive and negative on the silic layer. Okay, diode is in. Then we have the inductors. These are like that. I like to put the inductor close to the isolated DC to DC converter. Yeah. And the other one like so. 10 micro henries inductor is this. I don't know how much power, but it doesn't need much power because the gate driver isn't demanding a lot of power. Alright. So this is where the power enters the DC to DC converter. Again, some clippings. And the diode, is the diode correct? Yes, it is in place as it should be. Solder it nicely into place. Yeah, one is positive, one is negative. Fine. So it's reverse connected over the power supply. So when the power supply is reverse connected, the diode will conduct, which will make a shortcut, which will burn out the fuse. And that way everything is protected. Alright. Next, I think we're at the point that the capacitors are coming in. You can see I used a whole lot of capacitors, and they are actually powering the gate. So here's 3 capacitors that charge up the gate of the high side MOSFET, and here are the capacitor that discharge the gate of the high side MOSFET. Same here, this is the discharge capacitors of the low side gate of the MOSFET, and here are the capacitors that charge the gate of the low side MOSFETs. Then I have several capacitors here that regulate the voltage supplied to the DC converters. The 5 volts here, and isolated DC drivers here that are on the bottom side. Then another power cap, and these are for the fans also. And then there are only diodes and MOSFETs left. So I'm gonna clean up a little bit, get a lot of stuff out of the way that isn't needed anymore, so I can work a little bit cleaner with all the parts and see what I'm doing. These tools are still needed. That is needed, this is not needed. And this is not needed, that is also not needed. Okay, let's get some capacitors out. Oh, I see now. I actually had these bigger 10 microhenry inductors for here. These can take a lot more of power. And these are the 3.3 micro Henry. These are the 1 microfarad, and then the large capacitors. These are the 47 for the 5 volt side, minus 5 volt. Yep, that's one. Then we have the 680. And those are much too large. Let's put those in first. Let's see what I'm missing. Check. A sip of tea. Ah, delicious. I should check. Well, it says I need a 10 microfarad capacitor, but instead I will use a smaller 4.4. And why do I do that? Because I don't have the part. And the 4.7 microfarad capacitor is not electrolytic, because these things can't, these electrolytic alco capacitors can't handle high frequencies, and these can handle high frequencies. So I put those in here. This is for filtering the power supply of the DC to DC converter. From here it goes to the inductor and into the 12-volt input, like so. This is the larger 630 microfarad for the 15-volt supply. I need to watch polarity here. Longer lead is positive, and it will snap in like this. It isn't a perfect fit, so I should make a note of that. That I should widen those. Widen gap. What is this? 18 and C1, and then C6 and C19 also, probably. So same cap for this part. Positive is the longest, first in, then the negative. Again, it doesn't fit perfectly, but it's good enough. It will work. And two more. Those are the smaller caps. Did I break this one? No, it's the wire. I shouldn't pull those out of the paper, that's pretty bad. Just snap them off. Watch out for the polarity, because now one isn't longer. The negative minus 5 volts has a smaller capacitor. Like so. No, this isn't right. The smaller capacitor is, this is wrong. The big capacitor is for the minus 5 volts, and now it fits a little bit better, looks like it. And the smaller capacitor is for the plus 15 volts. Yes, there's a logic behind this, that's why I know I made a mistake, because I love logic. I like to understand how things work, why they work, the wisdom behind it. So now positive is here, negative is there, reversed, and again I made a mistake. This should be in reverse. Glad I'm catching these mistakes while I make them. This is really important, else you will blow out everything. Now I'm also doing another mistake, and that is I'm placing big parts first, while I have these smaller parts that should be placed first, because that's simply easier to access. But it's no problem, you can work around it. So 6 parts, solder them in place. Solder iron is hot. Take a sip of tea. Ah, lovely. Lovely. Cinnamon. That's one. Oops. That was a mistake. And 2, 3, 4, 5, 6, 7, 8. And then the other ones. 1, 2, 3, 4. Now I'm gonna correct my mistake. This is, by the way, also great material. Wick rosin. It's just copper with some resin on it. Now I tipped one bit of solder here where a capacitor should go. So I heat it up and now the solder flows into that copper. And now the wire, the copper is gone and the hole is open again. It's really great tool. Use it a lot, especially when I need to clean things up, remove parts. It's probably also what I'm gonna use with the board that is now sitting there waiting to be recovered. But that's not for now. Different priorities. Now I have 2 more capacitors here. These are in parallel. Actually only one is really needed, but I use them for the DC to DC converter, but that's not really true because it doesn't need it. They're mostly used for the fan, so I will give it a small capacitor of 100 twice 100. That's not much, but it's enough. It's not critical. So positive first. It fits. Last time I made these didn't fit, so corrected them. Positive first, longest lead, and the negative. Please go in, thank you. Negative, positive, right. And slowly the PCB board is assembled. Like so. Alright. All good. I could also connect the other coax. Let's do that. Because I'm thinking about it, and that's probably the right time to think about it. Yeah. Oh. Adjust my chair a little bit. That's better. These coax PNC connectors are flush to the PCB, so they could be mounted inside a housing and connected to the housing by the BNC connectors. But then I made the 12-volt connector also here, so that's not really, well, that would not be used. Well, anyway, it's not for now. Let's put this one into place. First put the solder on the biggest parts, heat them up with a lot of solder so they will stick properly. Then the leads, the ground, and the signal for the gate driver IC, like so. Alright, then we have some, this is 3.3 microfarads that goes in here for the 5 volts discharge. I see now the bigger capacitor, it doesn't really fit, but it's good enough. And the same for the positive voltage, which actually could be a smaller capacitor, but doesn't matter. It will be cheaper, but it will work. Again, the big capacitor doesn't really fit, and the small capacitor does, so I should make a note of that. Adjust position of -5 volt cap, and that is C18 and C1, if I'm correct. C6, sorry. Okay. So now these bigger caps are a little bit squished aside. It's not bad, but it's not really how it's supposed to be. Solder them. That doesn't look good. That was the one that was soldered before. Okay. Clip it off. It's almost nothing, but we're working on AM radio frequencies here, so best to keep everything tidy. Let's see, we have got some 1 microfarad. I'm gonna cut off. These also have no polarity. Now I know why this is a mistake. I plan to use tantalum capacitors here, but they are not only expensive, they are also not so nice for the environment, for Earth and its citizens. So I just use polypropylene and multi-layer ceramic. These capacitors are C3X73 and these are very expensive. I believe even €1 per piece. 1 microfarad, 50 volts, multi-layer, and these are to provide the very fast currents to charge the gate up and down. And this way, what happens? See, now I have the small part and I have the big parts already on, and now the small part isn't accessible to the PCB, and you have to get it into place, and that's tricky. That's why I should place them first, and you should too, and then use the bigger parts, and that way you can keep working properly. So the idea is, I really need a little helper. The idea is that the DC to DC converter that is isolated, that is referenced to the source voltage of the MOSFET, which is changing in voltage. This DC to DC converter provides the voltage to switch the gate on by charging it high, like a capacitor, and then switching it off by discharging the gate of the MOSFET to source. And for that you need current. A current charges up a capacitor, and the current again is provided by a capacitor. The capacitor discharges, and this capacitor discharge is made by the supply of the large electrolytic capacitor, which isn't able to provide high speed currents because its internal resistance is relatively high, and then this feeds the faster polypropylene capacitor, and that charges the ceramic capacitor, and this ceramic capacitor is the fastest, that gives the fastest currents, which is the closest to the gate driver IC, and that whole path should be very small. The path from source to gate is a resonant circuit, which is dampened by the resistors, and by making the path really small you have little ringing. Okay, let's solder those final capacitors. Actually, what would be advised is not having a 1 microfarad here, but 100 nanofarad. But that would be for very high frequencies, and I'm only switching at 100 kilohertz, so actually it doesn't really matter. I just really need to open and close the gate really fast, so I need high currents, and these are provided by the capacitors. Making them larger keeps them charged. Because I don't need much charge. So actually I could make them probably smaller, which makes them a little bit cheaper. So yeah. So yeah, this is swiggled because that would be a tantalum capacitor that I don't want to use. So there's a bigger capacitor here now. Okay, that's all done. Then I'm going to need the power supply of the 5 volts of the input side of the gate driver IC. Those are simple regulators. Am I still recording? Yes, I'm still recording. What did I need? I forgot already. Oh yeah, the power supply. Last time I checked, I needed to reorder them. So I hope I still have some, because I need to. Let's see, why did I keep those? I believe it's in here somewhere. Not that one, this one, I believe. No, also not. That should be this one. Yep. LM78L05. I still got a few of them, I should order them. Let's make a note of that. Order LM78L05 AZZ. So two of those. Tea is getting cold. Ah, now it's really strong. And I don't like strong tea normally, but this is with cinnamon, and when cinnamon is really strong, I am remembered of the taste of cinnamon chewing gum, which I had in high school, and I loved. Put them in right polarity, flat side, because else this won't work. I'm getting a message. Kom maar. That stand isn't perfect. I should fixate it. T. Before it's cold. Solder them in place. And the other one. Hi schatje. So snap it off. Snap it, snap it. Snap, snap, snap. Then I should have another capacitor for the stabilizer. I don't know if I should throw that away. Little capacitor. I just use this one. This is an old supply of capacitors. This picofarad, it's small, need bigger. 0.22 microfarad, that's more than enough. So I got 2 of those. I'm gonna go order C4 and C7, 22 nanofarad. These are to provide the regulator with stabilized voltages. And it's also not really necessary because we already got a cap here and a cap there, and you can see I have to redesign those parts also. Widen C4, C7. Because as you can see, it doesn't fit really nicely. But I just deal with it like this. Put the leads together so it will fit. This is not how you should supposed to do it, because it's extra work, and you should avoid extra work, especially when you plan to make a lot of these. Well, it's not perfect, but it works. Let's stick it on with a little bit of this eraser stuff. Solder it on. Yeah, it's good. And the other one, same. C7 is going in, please. Yes. Right. I'll just stick it on. Sticking out just enough to be soldered into place. Yep. Right, so far so good. What I can do now is provide this with power and test it. I should put in a fuse, because everything is now in. I should get the right voltages on the IC board. So let's do that. That's a fun part. Now, then we can see if it all works out as it's supposed to do. So I've got here positive and negative. I still haven't pointed out which is positive and negative, which is really important, because if you do it wrong, it won't work and you'll burn out the fuse. So those markings should be on the board at the fan right there. I wrote it down, so that's not a problem. So now connecting the 12 volts DC that I supply with a separate power supply, which could be from a buck boost converter that's connected to the coils power supply, but I like to keep it separated for research purposes. Okay, I'm injecting 0 volts because I have no fuse. I'll get a fuse. Where's the fuse? There is the fuse. Here I got a package of fuses. Always get more than one, because you'll probably burn one out. It's a 630 milliamps slow blow fuse. Well, first I'll turn it on, and zero current is running because there's no fuse. So if I now measure across the fuse with my voltmeter, it should say yes, there is a voltage across it. Very nice, cool. So turn it off, put in the fuse, which is a little bit, yep, well, that's nice, looks good, nothing wrong with that. And if I now turn it on, does the fuse blow? No, it does not blow. I have a small current running, which will light up the LED. It works! Amazing! Now I'm gonna check out the voltages on the gate driver. I see pins. So this is negative and this is positive. This should be 5 volts, and it is 5 volts. Beautiful. Then again, the same for this side, and it is. Very good. Then on the other side we have -5 and +15, which gives 20 volts around and about, because I'm not giving. Yes, that is correct. Now the source should be 15 volts, -5 and +15. That's good. Here the same, -5, +15. Alright, I like that. Now my supply is 11.4 volts. I will put it on 12 volts and see what I'm getting then. So now it's 12 volts. Now I've got 15.7 volts and -4.8, and that is totally acceptable for the MOSFET that I'm using. Yes, okay, so that part is all done. It's good. Very nice. I'm very happy with this. There's no heat development, any parts. You could use a special camera for that, but it's not needed. Turn off the power supply again. And continue working, because now is the hardware part of the diodes, the MOSFETs and the connectors. I'll first start out with the connectors. I've got these really nice connectors and I need 4 of those. Those are made in Poland, Phoenix Contact. I believe they're from Poland. No, I ordered them from Poland. They can, what's it say? KDS 2.5, 50 pieces, made by Phoenix Contact in Poland. So it is made in Poland. Doesn't say a lot. It's 300 volt, 10 amp max, and it's 24 to 12 AWG copper wire, so you can put in really thick wires and connect them up with them without any problems. That's really nice for the coils. Okay, put this back. How long is this recording going? I can't see, it doesn't matter. So, I see it's time for a break. But I will continue for now. These are for L1 and L2. L1 and L2 are labeled here, but they can swap around because this is all connected to the same. So yeah, that looks nice. I'll solder that in place because I have no worries about it. I know it will be fine. It's well designed, I'm really happy. Make a proper connection for these, because these are very important connections for the impulses to travel through. As you can see, maybe I use very large pads. That is because the impulse is a voltage event and it needs capacitance to travel on the outside of the conductor. Then I have two more of these. Always watch carefully where the wire is entering, because if you do it wrong side around, then you can't connect it. This is for the power supply. The positive goes here, positive voltage, and the negative voltage goes here. And this is the power supply for the coils, which is switched by the MOSFETs. Okay, also looks good. Solder them. 1 and 2. 1 and 2. Right. Now all that is left is the diodes and the MOSFETs. And they both will need to have cooling devices, cooling bodies. Especially the diodes, they need to stay cool. But so far so good. I'm really happy how this is turning out. It's a beautiful piece of work. Yes. Okay, break time. Let's see if my tea is still hot. No, that was cold, but that doesn't matter. It was a really nice taste. Back. Let's see if I can get some standoffs that will fit the diodes. Yes, like these. That's a bit much. One. let's continue. Brand new day, the sun is shining again. And what I've got here now is the cooling bodies for the MOSFETs and the cooling bodies for the diodes. And I've got some parts to be assembled. And I will first connect the cooling bodies to the MOSFETs. You can't probably see that because it's off camera, but that's not bad. It's just a little piece of work that I need to do. So I get one MOSFET. This is cooling paste, usually for thermal compound for CPUs, but that's all the same. And I put it on the MOSFET body for the conduction of the heat away to the radiator. Put it on, then I stick it on the cool body, and then a clamp is put on so it sticks. First the clamp is put on, then the MOSFET is sliced underneath it, and I hold it off with a little pincher. So I first put the cooling paste on the heat body, so I'm sure that it will connect. Now I put the clamp. I got the cooling body in a vise so I can work with it. And now I will use the pincher to open up the clamp, and then the MOSFETs will be pushed underneath. Yes, that's it. And then I push it in place, wiggle it a little bit so it's in the middle, and now it's good, like that. So now the MOSFET can be assembled like this. And another thing is I made extra holes here, so I could use these for the MOSFETs and stick them inside here, and that would be easy to change the MOSFETs, but I will not do that right now. Let's put on the other MOSFET again with some heat paste. That's good enough. Take the body, apply the MOSFET on its place, and then I twist it around, slide it over, and then pull it off. And now it's nicely covered. I put it in a vise, take the clamp, slide it into the vise from the side, and then use the pincher come on, slide in. Please slide in. Yep. Nope. I don't know why. Yeah, there it is. Slide it in from the side, open it up with the pincher, slide the MOSFET in. Yep, there it is. And wiggle it to the right position. That's it. So the clamp is clamping it down, and the cooling paste fills up the spaces so the heat is transferred. This is a certain amount of pressure, and these then will go in like this, one here, one there, and then solder them into place. They have some weight, so it's not really ideal, but the pins are strong enough to withstand it. But ideally I would make some standoff here so it would rest on it, but still for transportation maybe I need to make it a little bit supported. I don't know how. I'll have to figure that one out. So those are the MOSFETs. Now the diodes. The diodes will be like that. Same story. Take some cooling paste. So it connects to the cooling body. Just stick it on, wiggle it a little bit, like so. And then it's good. And the other one as well. Like this. Yep. I'm gonna use a small screw to fixate it. I'll use the screw from the inside out. That will be easiest. Yep, put it through. Yep. Hold it into place with my finger. Put a screw on it. Put it on. Then take the pincher. Use the pincher to hold the screw. And screw it down. Oh, while you're screwing it down, the diode will move. So it's best to put it in a little bit off position and then make this final adjustment so it's straight. Yeah, like that. It's really tight right now, so that makes a good connection. That's one. Another one through the hole. Nut, bolt, tighten. Screw it on. Put it in the right position. Tighten it and hope it will end up right. I'll just rotate it with the pincher. Like so. Okay, so these will go into here, so I have to bend the foots. Let's take the MOSFETs out for right now. Again, I forgot to take that electrostatic wrist wrap. It's very important with these devices because these are sensitive. That's why I use this special conductive foam to put them in, so they can't be damaged. So diodes like this, yes, like this, and then I'll bend the knees and I'll use the hole, the small hole, for this one. And let's do that first. I've never done that before. I ordered spacers for here, but I don't have them right now, so instead I will use a screw, I mean a bolt on a nut, and this will probably give the right distance to the diode, I hope. And that way, let's see. Yeah, as you can see, it's a tight fit now. Actually, it doesn't provide a tight fit. There's a lot more space than I needed. And that is because I miscalculated. Alright. So I just ordered the wrong spaces. Great. I can cancel the order. I'm going to cancel the order right now and order the right distance. That should be the best solution for now. Cancel the order very fast. Cancel order. Yep. Cancel order. Now I'll have to measure again with the caliper the distance from there to there is 6.03 minus 1.4, so that is 4.6. 4.6, then I'll get a 5mm distance. M3 5mm. Alright, how much? 150. Add to chart. Buy now. Yeah, that's better. Okay, pay now. Din 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 din. Pay. Okay. Okay. Okay, that's another save. Dun, dun, dun. Battery's low. Yeah. Okay, let's continue. So, if I put two of these on top of each other. Is that gonna be the right size? Because then I'm gonna fix it like that. Yeah, that looks so good. So, oops. Alright, now I use two nuts to get the right height. Like so. And then this goes on there, and then I should bend the prongs, what do you call it? The leads, yes. Okay, stick them in and see if it works. It does work. Yeah, it does work. Okay, now I'll need to fixate that again. It's gonna be a little bit harder because now I should have done that upside down. Let's do that because that's much easier. And this is how you learn. Make prototypes, make errors, and learn from your errors. That is a confirmation from my order. So how I'm gonna do this now is first put through the hole, put the distance nuts on it. Like so. Yes. And now, so I got the nut, two nuts stacked. Now it can go through the hole, and then I can tighten it, and then it's good. Still not ideal, this, but the diodes will be fixated. They're not floating anymore as I had before. When you float diodes on their leads with that heat body, it will snap off. Yeah, I like that. That's solid. And I made a hole here for the bolt, but I put that upside down. So it's a bit useless that the hole is there, but it's okay. It's no problem. So the order is made, that can be scrapped. The next diode, where is it? Here it is. And same story. Put the nut in first. The bolt. Bolt and nuts. Are you nuts? No, I am bolt. Remembers me of Jimi Hendrix. Bold as axis. I should play that song. But YouTube won't. Like that. YouTube. The platform has changed a lot. That's also a reason why I let go of my channel a little bit, because I wasn't interested in promoting my channel anymore because it wasn't worth it. You know, I'm a small channel. I'm relatively big because for a researcher like me, I've got a lot of subscriptions for the few videos that I have. But that's because of the topic. Okay, I like that. That's really sturdy. That's a good solution. Alright, then the MOSFETs, they go next to it. I'll put my soldering iron on. I get some bigger solder because these are big holes. Now I could place the MOSFETs in this position, but I'll just stick it with here. That's better. So like this, nothing touches. That's good because these heating elements are not isolated. I need some standoff to get them in the right position. That's good enough. Yep. And now I can solder it. Great. Are you sure? Yes, I am sure. Great. Is it hot? Yep. By the way, I'm using a Hakko FX888D soldering iron. Hey, where's my... What the hell? Ah. I forgot to put on my bracelet again. Well, that happens. MOSFET 1, MOSFET 2. I put a lot of soldering on the MOSFET, so they also have a larger pad, and this is to make sure that the MOSFET is connected properly to the PCB, as it also holds the weight of the heatsink. That's not ideal, but that's the way I made it. Put some extra solder in to make sure it's also on the other side of the PCB. Yeah, that's good. And then the last diode. Wow, this means it is almost finished. Snap these off. I used double-sided PCB traces. So the top layer and the bottom layer have the same traces, and these are pretty wide. I believe 2 millimeters. I did that because those impulses are capacitive and they need surface area to travel. Alright. Now I have some feet. I should have done that first. Again. Look at that! It's almost finished. Maybe I should have done one more thing. I've got fans for these, and I forgot to put them on. The weight is fairly around here is the here. So the weight is very much on that side because of the cooling bodies. And I have here 2 standoffs. So they're going to be like that. And then these can be here or there, and that will of course be much stabler. I even got one here. That's a bit experimental. I made several holes to be able to make choices, but you don't need to use every hole there is. Yeah, that's fairly accessible what I'm got here with the heating fans. The blah blah blah. Okay. Like so. And that's the second one. Now I use the bolts of that, so I should get some new ones. I'm almost through, so I should order more of these. Order 3mm nuts. And standoffs also. Order standoffs. And they need to be at least 2 centimeters. Okay. Now it's standing on the fuse, which is already good. Now the fuse is on the bottom side, so if I would ever fixate this on a enclosure and you burn out the fuse, then that would cause you extra work because you will need to disassemble it all. If you have the fuse on the top side of the PCB, then you can access it by opening the enclosure. But now you open the enclosure and you don't see anything. You don't even see the fuse like that. I mean, there's no way you see the fuse. So, maybe I should make a note. Top silk fuse 0.65. What was that value? 63 amp. Slow. Is there a place for it? Not really. I should place it maybe here, on the top side. Well, look at that, almost done. Yeah, so it now has feet. Is that stable? Stable enough. I can access here. The only thing left is the fans. Now I use 12-volt fans, and I connect them in series, so they only will get 6 volts. And I tried this before, and that works fine. It's the Sunon 12 volts, 1.14 watts, and yeah, they'll be like this on top of the MOSFET, a little bit towards the. Maybe I can even put them on the diodes, because the diodes are really in need of being cooled. First I'll connect this black wire to the red wire, make them in series. And this provides them with 6 volts, which is really nice because they don't need to run full out. Just blow a little of air, just enough, because not a lot of heat is coming off. It's just, maybe even I will leave them out if I test the heat body, but before I had a lot of heat, so maybe that was an error of some sorts. It depends on the diode. This is too small. No, it fits. Okay, snap it off. Where's my fire? There's my fire. Heat shrink. That's it. Okay. Face down. Like that. And this is a bit long, but it doesn't really matter. It's not important. That's for future. Blah. Okay. So positive goes there. Give him some space. And negative goes there. Okay, almost there. Really like how sturdy it is now. I can really move it around. So you can see, maybe you can't see. Yeah, camera is dead closed. The solder in the middle pin of the MOSFETs hasn't come through, so I'm going to give that some extra heat and solder and see if it will come through. That's probably because it is straightly connected to the heatsink. It is the drain. So it won't heat up as much. It's still not through. Wow, that's good enough. It will stick. So give this a little bit solder. Let's take the small solder again, because that is a millimeter wide solder. Twist it up. I'm really excited. I'm almost done. That means I can go and test it. Hook it up. See if it works as it should work. Okay, positive here. Negative there. Okay, that's good. And get some tie wraps to stick those fans on. 2, 4. That should do it. Well, now I'm gonna I said 4. Then I get 3. Is there one on the bottom? No. Four tie wraps. Let's see, how can I connect this that it will stick and work? First, let's put on some DC power. This is positive. This is negative. Okay, 12 volts. Now these fans have a little bit of like 3 brackets, so they are protected and they're sitting pretty deep inside, so I think I just can lay them down like that and not have any problems with them. Turn it on. This is very silent, but definitely airflow to cool the diodes and the MOSFETs. The MOSFETs don't really need the cooling. They are power MOSFETs and they can handle a lot of energy, so they won't become hot, and this is all due to the very low drain to source resistance. I believe this one was 65 milliohms. Okay, so that works. If I now put a tie wrap around it, then it will snap off like that. In other prototypes I had the fans on the MOSFETs. Wait, if I just put the fan on the diode and put the wrap around it, how will I fixate this? This is a little bit of a problem. I would like to get it like that. And so that way both will get the air cooled. The cooled air. Yeah. I'll turn it off before I hurt my fingers. I know somebody who hurt his fingers with a fan, and I haven't heard from him from a long time. I hope he's well, but it looked like he went into a depression or something like that, which I can't imagine because he really hurt his fingers. He had 2 fingers that were mangled by a very powerful fan, and yeah, I think he had some stuff to work through. I'm not sure, but I'm hoping he is fine. Okay, this here, if I now put it on the other side of the MOSFET, would that work? Could I make that like so? this one here. No, it's too short. I should have known. Can I fix that? Well, will it work if I tighten this like that? It's just like that. Well, there's no other way. I will do it like that. That's good enough. Sometimes things aren't ideal. Here is that little... I should be able to make it loose. Or just get another one. No. Okay, you saw what I did? Recycling. Sorry if the camera is too far off. Okay, that's good. Put it in position, tighten the... Really tighten it up. So it will stay in position. Snap off the excess. That's pretty tight. Maybe can tighten this even more. No, it's good. Okay, so it's on the MOSFET and it will blow also on the diode, like so. There will be airflow enough. Just a little bit extra. In the end, probably I won't need it at all because the cooling bodies are enough. Like so. This one here. Yep. That looks good. Sorry. Did you like looking at my hair? Alright. Tighten it up. Fixate it. Now I can bend them a little bit to the outside, so the diodes will have even more cooling. Fine! This is all good with me. This is the way it should be. Now I can start testing it. Already tested the voltages on the sockets of the gate driver ICs. Those were fine. I should wrap this. I should have twisted this, but that's all not as important. Turn off my soldering iron because it's done. I finished. I finished. So this is the final product, the radiant gate driver. Now I can connect the BNCs of the dual channel signal generator that will make the 49 duty cycle square waves, and I will connect the symmetric power supply capacitors. I'll show it right now so you know what that is all about. So I've got this piece of work here. The capacitors are way too big. That is because these are from my DC offset projects, and these capacitors can have 2000 volts DC, which is absolutely unnecessary. It is not needed. But I had the caps, so I reused them. This is 2 times 680 nanofarads. In parallel, this is also, and those two are in series again. So you can see here the power supply comes in, which is symmetric. So I got positive and negative, and then in the center is earth ground again. This is also grounded at the power supply. And then I got the leads positive and negative, and here the coils can connect. I've got multiple connections, so I can experiment in different ways, but I only need the ground connection for the coils, 2 sockets, and I use those. So what I do is I put it like this, put this here underneath it. I have to make sure I won't shortcut this, so I'll have to protect that, but still in prototype phase. And then I put the positive here, positive there. Let's connect it up. And these leads are a bit long, they should be shorter. Still experimenting. It's good enough. So now it's hooked up to the power supply. Then the BNC comes in here. Let me show you. I'm so very proud of this. Make a little bit more space, because it's a mess. It's a mess. Look, this is the previous board I made. And this board had a failure. Well, it works fine, but you can see I used different isolated DC to DC converters. And that is because the MOSFETs I used were 1200 volts from the C2 version of Wolfspeed. And these used 20 volts on the gate. And because the problem with this was I had 1200 volt MOSFETs, so the impulse would rise to 1200 volts, and then the body diode would go into avalanche mode, which basically is a little bit like a Zener diode. It will stop the impulse voltage at 1200 volts, but the diodes that supposed to protect the power supply, or which prevent the impulses to escape, there are only 1000 volts, and these do not have the Zener functionality. They do not have avalanche mode. So if I would go over 1200, over the 1000 volt rating of the diode, then they will be destroyed. And now I have 900 volt MOSFETs, but these are from the C3M series of Wolfspeed, because these C2M weren't available anymore, and these work with 15 volts on the gate, and therefore I needed to get the 15 volts isolated DC to DC converters that gave the power to the gate driver ICs. Now I've got 900 volt body diodes that will go into avalanche mode, and I hope, and this is what I need to test right now, that the 1000 volt diodes will be protected by the 900 volt body diodes that will go into avalanche mode. And this way, if I go too high in the impulse voltage, the diodes won't be destroyed, as the body diodes can handle that. They will transfer it into heat, and that's why I got these fans here. So, okay. So this is a BNC connector for my square wave generator, which somehow is a little bit stucky. And this is the other signal generator. These square waves are out of phase, so the MOSFETs will separately go on and off with a little bit of dead time, where the L1 coil can become resonant and produce the half wave that is the impulse. Now the coils L1 and L2 will connect here in the middle. Sorry if I was in front of the camera. No, I wasn't. So here in between is the socket for the coils L1 and L2, and the outside rims of L1 and L2 are connected to the ground of the supply. In between the L2 and the ground of the supply will be the series capacitor, and I use a tuning block like this, so this will be grounded, and then from here on to L2 coil, and the L2 coil inside rim is to the connectors here in between the MOSFETs. And that concludes this video for now, because I will be testing this and I won't record that. I just wanted to show you the build of this board. I of course need to put in the sockets, the ICs that are here in my old board. This is one gate driver IC, and now I should have my wrist wrap on. Let's do that. It's a bit, I don't really believe in it, but I should do it. Okay, so now the board really is finished and working, and I can test it. If I put now a probe on the oscilloscope here and I turn everything on, I put the signal on, then I should be able to see the voltage here in the middle between the MOSFETs go high and low. When the MOSFET is on, this will be high. Is this MOSFET on, then it will be low as the power is supplied, and then I'll know it will be fine. But I'm not sure. I need to test that. Donations are always much appreciated, because this work is all open source, meaning that I will share all the information that I gain with the community that is interested. You can fund this open source research by giving a donation on my PayPal account that is listed below in the description of the video. If you have questions, you can do so in the comment section below. Please subscribe, like, and share this video, and turn on notifications if you want to get a personal call when my next video is out. Thank you for watching, and see you later.